Of course it's a gamble. Every time you launch a new commercial aerospace program, you're more or less betting the farm that it's going to be successful.
This isn't just a beautiful wing. Inside this wing are the fuel tanks and a very complex fuel system.
You're working on something so different compared to anyone else. Some of my friends, you know, working down Astor, I get to work on the A380.
As this wing unfolds, you'll see how big it is. You'll see what a massive task it is to take it out. You're actually standing there and you've got 29 ton in the air.
There's so many different parts and you just got to know exactly, like the ailerons and the AGS. If you don't know what they're talking about, you're lost with what to order.
This year we're building 4 wings like this per month. Next year we'll ramp up to 6 per month. It's a tough job for the whole team in the factory, but we'll get there.
Every single component has to be right. We always joke that when the paperwork is heavier than the aeroplane, you're about close to getting it right.
Nestled among farmland in North Wales, this is the Airbus factory in Broughton.
It's the biggest manufacturing site now in the UK, over 6,000 employees. We're enormous. We actually did the sponsored run around the site. I think it was something like 5.5 miles to run around the site.
And the people that helped build the world's biggest passenger jet are arriving for the morning shift.
Has anybody talked to you from...
Factory boss Paul McKinley starts each day walking the factory floor, keen to see for himself that things are running smoothly and no detail goes unnoticed.
It's so much more expensive to dispose of contaminated waste, so we need to make sure that we segregate in the right way. And that's one of the things I'll do during process confirmation, literally go and have a look in the bins.
When the A380 factory was opened in 2003, it was the largest to be built in Britain for 20 years. But for the people who work here, it's more than just a workplace.
The community feel is important. A lot of the guys live locally to the factory. People are excited by aircraft and love working with aircraft. And I think that's what makes a lot of us stay.
The Airbus A380 Super Jumbo was launched in 2007. And today, there are 53 already working the skies. Having spent an estimated £10 billion developing this plane, the company needs to make as many sales as they can. But building planes on this scale is a monumental task. Aviation history is littered with failed attempts to go this big. Like any big passenger jet, the A380 is first manufactured in smaller sections, with the fuselage, nose section and tail fin made in different sites across Europe. However, the greatest technical innovation on this plane are its enormous wings, and they're made right here in the UK. Broughton has a 70-year history of making wings, so Airbus decided to manufacture its A380 wings here too. Demand for the Super Jumbo is running high, with well over 200 now on order. And so the major task that Paul and his team of engineers face is how to build all those wings on time and on budget.
I mean, the production flow is critical. On A380, we're ramping up. This year, we're building 4 wings like this per month. Next year, we'll ramp up to 6 per month. Our aim is to try and make 6 wings a month with the same number of operators that today we make 4 wings a month.
With an increased order book, it's critical the workforce hit delivery times. If they succeed, they'll secure thousands of highly skilled British jobs for years to come. But any delays in production could have serious consequences.
It's a tough job for the whole team in the factory, but we'll get there. We've got a great team. The attitude of all of our people is to try and succeed on challenges. So I'm convinced we'll get there.
Each set of wings begin life as a collection of raw materials and arrive from all over the world, with some big enough to stop traffic. This cargo of 33-metre-long blocks of aluminium is bound for the panel-forming area of the factory, where manufacturing manager Mark Farrell is arriving for his shift. Everything about the wings is on a monumental scale, and the aluminium plates are loaded onto Europe's largest milling machine.
Right, this is the start of the journey. We're starting to mill it now, and this is where it starts. It's a long road, ends up on an aircraft, and when we see it flying over, you get an appreciation that actually that started here at Broughton.
Over a period of 72 hours, the panel, with all of its intricate features, is carefully sculpted out of the metal. By the time they're finished, there's more aluminium in waste than the panel itself, but it's all recycled. The next stage for the perfectly carved panel is to shape it to the precise aerodynamic contours demanded by the designers. So it's sucked onto a specially moulded bed.
The panel's now been moved onto the transfer. It's now getting, the actual shuttle was moving across to line it up now to go into the oven. It is the biggest oven in the country. When the oven was actually brought into Broughton, we had to have British Telecom working with us because all the telegraph lines had to be removed while it travelled through, and then when they'd finished, the lines had to go back up.
Heating the panel to 160 degrees in this massive oven locks the aerodynamic curve in place. The A380's wings can lift 560 tons of super jumbo to an altitude of 12,000 metres and fly the world's longest routes. It's an amazing feat of engineering. The reason it's possible lies in the shape of an aircraft's wings. Wings are curved on top and flatter on the bottom. This shape makes air flow over the top faster than underneath. This means the air pressure is lower on top than below, causing the wing and the plane to lift up. The A380's wings are also more fuel efficient per passenger than an average family car, making them the greenest in the skies.
This is the LCM treatments facility in Broughton. This is the biggest surface treatments plant in Europe.
Once they've been heat treated, the enormous panels go through 12 treatment baths to clean and protect them. Europe's biggest surface treatment plant is a fully automated facility operating 24/7.
This is critical to the process, but one thing you don't want is contamination going into the fuel systems. It's an old saying, but there's no hard shoulder at 35,000 feet.
Of the 6,000 or so employees at Broughton, 300 are apprentices, and one of them, Holly McCready, is arriving for day one of a new wing build.
Me and the girls went on holiday last year and we were speaking to people and they were like, where do you work? And I told them that I work at AIRBUS as a higher engineering apprentice, and I sort of get the, no you don't. More and more girls are getting involved in it. It's just a lot of people don't believe that you work here when you say you do. And if they do, it's, oh, you're a secretary then. And I'm not, so. How long does it take to come down then usually?
It takes a good 4.5, 5 minutes for it to come down.
Oh, okay.
It's not that quick, you know.
Holly is learning the ropes with the Heavy Gang, the team that work the 12 massive cranes that span the whole factory. Today, a delivery of major components has just arrived and needs unloading.
Right, so as we're coming down slow now, I'm sort of keeping an eye on the silver beam underneath in relation to where it's going to sit.
I'm quite lucky really because they're all lovely, lovely fellas. It's a really nice environment to work in. Strangely, you wouldn't think so, but it is.
The job of ensuring that components from all over the world are all delivered on time for the build falls to the people in logistics. And it's what Holly has decided she wants to make her specialty.
Logistics is pretty much what makes everything run in Airbus. On each part that you see, all the nuts, bolts, all the small parts, they're all come through logistics, as well as all the large parts from all the different suppliers. There's hundreds of suppliers that work for Airbus all around the world, so it pretty much keeps everything happening. Without it, nothing will get built. I wanted to be a hairdresser. Yeah, I did.
There's nothing wrong with that.
You realise until you get your first pay packet, though, don't you? But there's so many different parts. It's hard getting to graphs, and you just got to know exactly, like, the ailerons and the AGS, because when you come into the factory, if you don't know what they're talking about, like butt straps and things like that, you're lost with what to order, so you really do need it.
The A380 has around 4 million individual components, with the wings themselves containing nearly 500,000 alone. That's not surprising, given they're brimming with technical systems. They carry most of the aircraft's fuel, including a complex system of tanks and pumps. There's 37 kilometres of wiring, piping and ducting that drive all the flight control surfaces. And the wings have to carry 4 massive jet engines, which weigh over 6 tons each. And finally, there's landing gear, capable of withstanding an impact weight of 560 tons and landing at speeds greater than a Formula One racing car. The wing is now ready to be assembled like a giant Meccano kit from the rows of parts that are ready and waiting. To do this, each wing needs to go into a massive construction frame known as a jig, and these are the biggest the aviation industry has ever used.
This is the main assembly jig, the heartbeat of the factory, where the wing starts coming together. The jig is now being prepared to start its production cycle. So as you can see, the guys are just checking all the location fixtures, all the location pins, oiling and greasing, ready for the next set of components.
The heavy gang get to work. First in are the rear spars, 3 long sections that form the spine of the wing. These spars are fixed firmly in place to the 45 locating pins and will bear the whole weight of the wing that'll rise up lengthways in the jig. Over the next 5 days, the team load all the 49 ribs that run across the wing. The ribs are made from aluminium and carbon fibre composites, materials both known for their strength and lightness. Finally, the frame of the wing is fully assembled, and the skeleton is ready to be covered with the huge aluminium panels that form its skin. Giant automated machines drill holes in the panels, a total of 250,000 per wing set. And the panels are lifted into position. After 25 days, the main body of the wing is complete and it's ready to come out of the jig. But it weighs nearly 30 tons and is 4 stories high just lying on its side. This is definitely a job for the heavy gang.
Heavy gang is the lifting team.
Do all the heavy work.
It's not heavy gang because we're all big, fat and old. It's heavy gang because we lift heavy things.
Only the most skilled and experienced crane operators can handle a job like this. And Al Burley is the gang leader. Al has the unenviable task of getting the wing out through a gap with only a metre to spare either side.
We're going to take the wing out, put it on the turnover jig, lay it down safely, we hope. I must have been involved in about 70 to 80 wings.
down a bit, please, Jerry.
8 years ago, Al lifted the very first A380 wing out of its jig, but this one will be his last.
I'm retiring tomorrow, so hopefully the cheque isn't in the bank yet. I want it to be in the bank before anything goes wrong.
That'll do, Jerry. That's it.
Like a lot of people in Airbus, Al has worked at the company for many years.
13 years, 4 months, 2 hours and 15 seconds. It's been a nice place to be, this side. See that sleeve hand on your... Just ease that sleeve out.
It's time to begin preparations for the big lift.
OK, coming down.
Despite its size, the wing is a very delicate object.
I'll put the weight on that after hand.
The strongest points on the wing are where the 2 engines will be mounted. These titanium brackets will be sustaining the entire weight of the wing during the lift, but must remain perfectly intact after. As the jig is pulled back from the wing, the narrow gap it will have to pass through on its way out becomes obvious.
Do you want somebody on the very top? I'm on it.
The smallest dent would mean a serious delay, and with the rate of production increasing, there really is no time to spare. The heavy gang workers and team to release the wing from its moorings.
Moving all the pins out of the rear spar flags. If they're left in, when we try to lift it, it'll either rip that part off the wing or it'll rip the jig bit out. So it is important to get them all out.
Massive, isn't it? You don't really appreciate how big it is till you stand here, because I'm here. And they've got the rest of the wing, haven't they? It's unbelievable. And it's even more daunting when we take it to the ceiling, because you're actually standing there and you've got 29 ton in the air. As this wing unfolds, you'll see how big it is. You'll see what a massive task it is to take it out.
A final check that all the pins are out, and it's time to release the master pins, leaving nearly 30 tons of wing hanging from the crane at just 2 points.
Right, Al. The last one out now.
Ready?
Yeah.
Do it.
Right, the wing's free. I'll get the radio. And on my commands, we'll get it out.
Got the radio. We're ready.
Right. Take it up on the boat, one, please.
12-8 on the inboard, 6-9 on the outboard.
Hang on, hold it there. Jimmy, stop. Jim, stop. No. Hang on, it's going to come over. Chris, loosen yours off, tighten yours up a touch, Jim. Right, Al. Take it up again, one on both, please.
19-8, 6-7-5.
Hold it there.
Right, Al, we're ready for you to come west.
Kirk, take that chain off, mate, please. Cheers, Jim.
Going up.
Finally, the largest wing in commercial airliner history takes its first flight. Only now can the sheer scale of the A380 Super Jumbo be truly appreciated. One of its tailplanes alone is larger than the wing of an A320, the favourite carrier of budget airlines. And the wings themselves are a whole 50% bigger than those on a jumbo jet. In fact, this Super Jumbo would be a tight fit in Wembley Stadium. The wings are over 10 metres wider than a football pitch. But covering an area of over 400 square metres, this enormous wing will, when it's finished, fly more efficiently and more quietly than any of its current commercial rivals.
crane's broke down. John, can you get us box 1, please? Pardon? Well, that's...
to the lock, to latch it over.
Well, that's what I've got to do. I've got to take it back
right.
that way, because otherwise I won't get it on. See the turning on? Try one at a time.
See, that one doesn't look...
There we go, lads. We're in business.
A momentary loss of signal with the crane is re-established, and they can finish the job off. After 30 years of operating heavy machinery, Al's ready to land his final wing.
OK, that's the end. We're going home now. These lads here, they're more than capable of looking after the job. We need a couple more because we're going to get busier and busier and busier. But as long as we can get them out as good as this was, we won't have a problem, will we? OK, is that it? I've got to go. Thank you.
With the wing now out of the jig, it's time to check whether this hand-built creation is actually the right shape.
Right, I'll shoot the top point now. So if you kept that first point, yeah. Laughing. OK, mate, it's good to go.
Alex Jones has recently become a metrologist, an expert in precise measurement, and it's his job to make sure the contours of the wing are exactly right.
Precision is key in this job. It's got to be right first time, hasn't it? The laser's shot into the 3 mirrors on this corner cube reflector and then bounced back to give us measurements all over the wing so that we can make sure that it's aerodynamic in flight.
The shape of the wing has been painstakingly designed to have particular aerodynamic properties. They make it as efficient as possible.
Because each individual one is handmade, not made by robots. You get some slight variations that need to be sorted out or have the final finishing touches done to them. And we've got set tolerances on each individual point, which can be down to hundreds or thousandths of millimetres. OK, mate, yeah. Next one.
If anything is out of place, it could mean a costly delay to production while it's put right.
What are the figures like, Dave?
Yeah, just looking at the report, mate, they're all in. They're all good.
The team know they can't make a single mistake and are immensely proud of the work they do.
You're working on something so different compared to anyone else. Some of my friends are, working down Asda, and I get to work on the A380.
And there are other benefits to working at Broughton. A couple of times a week, Alex and his dad Gary head for the gym, built with the rest of the factory in the 1930s.
Like a release from obviously the pressures of working here. You've got everything that's got to be right, and then you can come here and let off a bit of steam. It's all good.
Fortunately for Alex, he's always been keen on planes.
My dad always used to bring in the little models from Airbus that he'd get, and I knew I'd be working here one day, and here I am.
I think Airbus at Broughton has had a history of families working at Broughton, father, sons, father, daughters, mothers. I've also got a brother working here. I left school in the mid-70s, joined as an apprentice, served the 4-year apprenticeship as it was in those days, and I've worked here ever since.
It's a lot of years service, 35. It's a long way off for me personally at the moment, but hopefully I do enjoy working here, so one day I might be able to say that I've worked here for 35 years.
Broughton has a long aviation history. During the war, Wellington bombers were made here, and at one point rolled off the production line at a rate of 1 a day. But another of Airbus's sites in Filton near Bristol has even longer aviation heritage. They've been building planes for over 100 years there, but are probably most famous for developing Concorde, which was designed and tested in its unique laboratories. And it's still the place where Airbus designs and tests their wings, sometimes to destruction.
211.
Yes, the bend on that.
Yeah.
You're looking for the last few % of improvement on every aspect of the design. We have to look at every nut, bolt, washer, rivet, everything is brought down to the minimum weight that maintains the safety and integrity. It takes the world's best engineers over a long period of time to get to this level of performance and efficiency.
Not many people realise that the UK has the second largest aerospace industry in the world, beaten only by the United States, providing UK jobs for 250,000 people. It's a fiercely competitive industry, and the battle for supremacy of the 21st century skies is now all about efficiency. It's a race to reduce the weight of aircraft, making them cheaper on fuel and cleaner on the environment. And although in production with the A380, the team are always looking for improvements. In a unique facility on the Filton site, engineers are about to run a series of tests on a new, lighter landing gear design. Stuart Hazelwood is the man in charge.
The tanks and these manifolds are exactly as they would be on the aircraft. Around the whole rig, all the pipe lengths and all the wire lengths are exactly the same as you would have on the aircraft's landing gear system. When any modifications are brought in, we are truly replicating what we'd hope to see on the aircraft.
The landing gear system is partly housed in the wing, and just like the real thing, the test rig is able to raise and lower the 22 massive wheels of the A380.
There's a lot of pride that goes on here, and when you see the aircraft flying or you hear good news about the aircraft, you sort of think, oh yeah, I've got something to do with that, which is quite nice actually.
Even though the plane is now in service, testing for safety is a continuous process. Every tiny change to the design, no matter how small the component, means the whole system has to be thoroughly tested again. And it's going to be a busy day for Chief Landing Gear Designer Nigel Owen.
The A380 has 16 braked wheels, 4 on the body landing gears and 4 on the wing landing gears, and we're currently developing a new brake, a reduced weight of brake and wheel. Overall, we'll save about the weight of a passenger, and this is the new brake which we intend to fit.
Shaving the weight of one passenger from several hundred tons may not sound a lot, but multiply that over 20,000 flights and you're looking at big fuel savings. Today, they're testing for the worst-case scenario. They want to ensure that even if the hydraulic system that powers the landing gear failed, it would still be deployed. It's called the Emergency Freefall Test. The landing gear is designed in such a way that they can push open the doors and drop into position under their own weight alone. It's a situation most pilots would never encounter. But now the landing gear is lighter with their new brakes, Stuart and Nigel need to ensure that the procedure still works.
We are here to find out if there would be any problems in certain scenarios. You want it to happen here rather than on an aircraft. You put lives at risk if it happens on the aircraft, so that's why we're here.
Months of design work will stand or fall on the result of this test.
I wouldn't say it's fun, it can be nerve-wracking because you don't want things going wrong. There's a lot that can go wrong as soon as you get big pieces of metal and rubber coming down.
After one final check, they're ready to run the emergency landing simulation.
There's always a slight tinge of apprehension when you're doing something for the first time. It's a major step on the development activity, a successful completion of a test. So let's get on with it, I think, and demonstrate it all works as it should.
Okay, base clear.
Ready to go? Okay, let's do it.
Enable the pump system now. Okay. 7 seconds. Should be 350 bars on the green system. That's 2 pumps on the yellow system. It's 350 bar and yellow pressure. Are you ready on the logger?
Yeah, ready.
Okay, you happy? Okay, ready for a free fall now? And start an emergency extension. Okay, cut-out valves have been selected. Vent valves selected. It's the doors. And those doors have opened. Gears are still uplocked. And nose. Bodies. Okay. That's the door shut. That's complete.
All down and locked?
All down locked. Door shut. No faults.
Great.
As a successful emergency extension.
It's great when it goes well. You put a lot of effort into it. Happens seamlessly, and when it goes like that, everyone's pleased, and you go home and look for the next problem to solve.
Although the wings are made in the UK, Airbus has test facilities all over Europe. Chief Engineer John Roberts is responsible for the ongoing development of the wing and is on his way to the German city of Dresden to visit one of his most important test sites.
I mean, I've got probably the best job in the factory. It's a great job looking after this aeroplane, and they pay me for it as well, which is good.
The Dresden rig is a test structure so large it took 2 years to build.
You always get a buzz and an excitement seeing the sheer scale of this test facility that we do here. If you don't get an excitement out of things like this, you're in the wrong business. And here we are. Welcome to IABG in Dresden.
What John's engineers are after is proof that the Super Jumbo and its wings are strong enough to last a lifetime of flight. To find out, they've spent well over £100 million on the largest test rig of its kind ever built.
Achtung, der Versuch wird gestartet.
The rig is essentially a giant torture machine to expose any weaknesses in the design of the plane's structure that might develop by simulating the kind of stresses a real plane would experience in flight over and over again.
The most interesting part of this test is the bit which takes all the punishment. The aircraft, when it's flying, all its loading is being taken up on the wing, which you can see up there. So all the punishment is being driven into the wing structure, and this is a demonstration of what it looks like while it's actually in flight.
A computer system drives a network of 180 hydraulic rams that bend and distort the wings.
It bends, doesn't it? You can never fail to be impressed on seeing something like that.
Computer modelling of real journeys means that, in this simulation, flight times can be reduced to only the bits of the journey where the plane is particularly stressed, like turbulence and landing.
From this would be a window which an ordinary passenger might be looking out along the wing, and in the test here the end of the wing is moving up by over 4 metres during normal flight cycles, and down when it's on the ground by nearly 2 metres. People always look out along the wing and see it bouncing up and down in turbulence and thinking, is this something that I should worry about? Well, we test it with the assumption it happens all the time. No, you don't need to worry about it.
And precise engineering ensures the wings bend in exactly the right way. The ability of the wing to take huge punishment is down to the design of its internal structure. It needs to be light, but also very strong. The ribs and spars give strength, but also just the right amount of flexibility to cope with the enormous loads on them. This fatigue test is the pinnacle of a whole testing program John is responsible for, to prove the plane is safe to fly.
In terms of proving the aircraft is safe, you have to put together a portfolio which shows everything from the individual little valve that sits within the wing through to the complete structure. As we always joke that when the paperwork is heavier than the aeroplane, you're about close to getting it right.
After 5 long years of continuous punishment, 24 hours of the day, an amazing milestone has now been reached.
An aircraft like this would do around 25 years of normal operation. We've demonstrated here the equivalent of 65 years of operation. And that basically confirms that the analysis that was done by all those clever engineers sweating over computers for years on end have been proved to be right.
It's quite an achievement, but John's decided that even though the plane could carry on going, it's time for the test to finally come to an end.
We'll basically cut out the bits that we want to keep for reference, and the rest of it will recycle as aluminium, so it will appear in a Coca-Cola can near you at some stage in the future.
Back in Broughton, it's shift change at the factory, and Janet Hardy is clocking on for the afternoon.
Fuel for later.
The wing is almost ready to be kitted out with all its flight systems, but before that can start, Janet has an important safety test to perform. As well as flying and steering the plane, the wings are also the enormous fuel tanks of the A380.
The wing's made up of little sections, and each one's called a rib. And certain sections are sealed, and those are actually the fuel tanks. In between each fuel bay, we have sealed ribs, and these are the ribs that we actually test to make sure that they're watertight or fuel-tight in this case. Okay?
The test begins by sealing up the tank that's going to be tested, so it can then be filled with high-pressure air.
You pass me my overshoes, please?
The only fail-safe way to spot a leak is to get up as close as possible.
You have to be a contortionist at times. It's not the easiest places to get to. Gosh, you have to be double-jointed.
Safely nestled in the next-door tank, Janet applies a solution to the seal around the rib.
I'm snooping the rib to see if I can detect any leaks.
If there's any air trying to escape, it'll blow bubbles, like a bicycle with a puncture.
It's looking pretty good so far, to be fair.
As safety is the top priority, it's a necessary task. But Janet's job is not for the faint-hearted.
When you first join Airbus, you are tested to see if you've got any problems with confined spaces. So in the training school, you actually go up head and shoulders inside a wing tank. They ask you to read some numbers off a card, and obviously if you've got your eyes shut and you're terrified, you can't read the numbers. I've got a bungalow, so maybe I'm more terrified of heights. But anyway, okay, job done. Time to have a cool down. Very warm and very sweaty. I don't know why I did my hair this morning. I don't think there was really much point.
Janet finishes off by testing the outside of the wing for leaks. This time, the tank is filled with helium. Any that escapes, she'll detect with a sensor. Once all the fuel tanks have been tested, the wing and its matching partner can finally be equipped with all the systems they need to fly. The wiring, piping and ducting for the hydraulics that connect all the controls and the fuel system are installed by 200 workers over 22 days. This is a vast undertaking, but the company has a full order book, and so they'll need to constantly look for ways to make the process more efficient. Today, their fuel systems specialist, Lorraine McKilry, is visiting the factory. She's on a mission to see if they can build the wings any quicker.
There is a lot of equipment in the wing, a lot of fuel equipment in the tanks. So we've got 21 pumps, we've got around 46 valves that are installed, and hundreds of pieces of sensing equipment that's all installed in the wing here. And we want to be able to see what improvements we can make to make that job easier along the way. The people here are doing this job every day, and they are key to be able to give us pointers or suggestions on potential improvements, so it's really useful to talk to them.
Today, she's looking at how the engine feed pumps are installed.
See, like there.
Yeah, I was going to say, I think we'll do the other one.
You need to be able to go in a bit easier.
Right.
So it's always like this.
Right, OK, well, that's quite easy to take on board, so yeah, that's really useful to know.
Making one pump easier and quicker to fit may seem fairly minor, but it's just the kind of thing that Lorraine wants to improve on to get the wings flowing out of the factory even faster. But for her, the wing is more than just the sum of its parts.
I absolutely love the profile of that wing, and whenever I see a 380, one of the views I most enjoy is the back of a 380 and that sweeping wing shape. Absolutely stunning. It's lovely, really lovely, and I feel really proud when you see that as well.
The sheer scale of the Super Jumbo called for a new type of fuel system. Fully loaded, there's up to 118 tons of fuel in each wing. With a conventional fuel system, that weight would put huge stress on them. So the designers created a dynamic system that could constantly distribute fuel around 11 separate tanks to ensure the weight was where it was needed. On the ground, fuel is loaded towards the centre of the craft to prevent the wings from bending down too much. But during flight, fuel has to be pumped out to the tips to stop them being forced up. Tanks are also located in the tail, and fuel is pumped forward during flight to maintain the perfect centre of gravity. This weight-reducing fuel system has helped the A380 become the most fuel-efficient airliner in the skies. But going so large could mean the plane taking too long to prepare for flight, losing money for the airlines.
If you stand next to it, you can actually, put that into perspective as to quite how big that tank of fuel actually is. That's a lot of fuel that can fit into that wing.
Fortunately, the fuel system has another trick up its sleeve.
If you were to take your 380 to your local petrol station to try and fill it up with fuel, it could take up to 6 days to fill up. So on 380, we have a complex refuel system which will enable us to potentially fill the aircraft ready for dispatch in 45 minutes.
Airlines are always keen to reduce the amount they spend on expensive fuel, making fuel efficiency a constant subject of competition in the aircraft industry. So, although the A380 wing is the most fuel efficient there is, the company has been redesigning it to make it even lighter. It's been Chris Benyon's job for the last 2 years to implement all those design changes into the production line.
It might seem quite small to maybe reduce this web thickness by 1 mil, but when you do so across the length of an aircraft, then things soon add up and they soon start to impact on the overall weight of the wing. We made a lot of changes to a lot of parts, and when that came together, then you start talking about the substantial hundreds upon hundreds of kilogram saving.
If they've got their sums right, all of this should add up to about 350 kilograms per wing. Enough to save several £1 million when calculated in fuel savings over the lifetime of the aircraft. And there's only one way to find out if all the hard work has paid off. It's 2 in the morning, but this factory never sleeps. A team has been assembled to perform a special task. The first wing with all the weight reduction modifications is about to come off the production line, and it's time to prove whether it's as light as it should be. Stuart Sutton is a man with a very large set of weighing scales.
This is a 20-ton weighing cell. We use 4 of these on this weigh. We're just attaching it into the lifting system.
It's time to get started, and the lifting beams are married up to the wing by 4 small sockets that will bear several tons each.
6.3, Joe. So take it up on both to start with. We'll keep an eye on the 2 plumb lines. Hold it there. Up on the outboard. Down on the inboard. Down a touch. Whoa. That's fine. Right. We'll take the figures on that.
The predictions and calculations done by computers are now about to be put to the test.
Bit of movement. Any movement in the crane system. So they've got a bit of a bounce. We'll settle now. First impression, that's good. It is the 350 kilograms lighter that we were expecting. I think they'll be happy with the results once they get them.
2 years of hard work by hundreds of people has finally been vindicated. The wing is lighter and greener while safely maintaining its strength.
Gone smoothly. Good team effort.
Factory boss Paul McKinley is in a good mood. Another wing is about to roll off the production line. But also, the company's football team, AIRBUS UK, is on the verge of breaking through to the semi-finals of the Welsh Premier League. There's been a football club on the site since 1946.
I do wear 2 hats. The proper job is head of the plant here at Broughton. My fun hat is being chairman of the football club. And you can see from the crowd we've got here tonight, there's probably, I don't know, nearly 400 here from the local community. The football club and the company plays a big part in this community. You know, you come here on a Friday night after the tough week in work. It's a good way to relieve some stress as well from the workplace. Go on, Shed, get in! Go on, Shed!
Penalty, it's a penalty to the other team.
What a save that was! Hey, Reg, you couldn't have done that. You'd have held it, wouldn't you? I like winning in everything I do. We always say play football, there's no such thing as a friendly. Don't play to... You know, you play to win, and I do everything that I do, just you give your best, and you want to win, you want to be competitive, and, you know, people have different strengths in the workplace, and part of having a team is bringing the different strengths and competencies of that team together. Go on, Shed, you can get in, you've got the pace. Oh, keep hold of the ball. Oh, no! Point's okay. Could have been none, and we needed a point tonight. So, yeah, you take it and you move on.
Morning, and a set of wings are ready to leave the factory. Each wing is shrink-wrapped to protect it from the elements on its 28-day journey to Toulouse in France, where it will be joined up to the rest of the plane. The first leg is by river, but the barge is a mile away, so first it'll have to negotiate a country lane. Not easy for something 39 metres long, so it's one wing at a time.
Just take this wing out now. That's our main thoughts, to make sure we don't hit anything, because that'd be embarrassing.
The wing inches along, and an hour later departs for the coast on the River Dee. Both wings are then loaded onto a specially built ferry, ready for their journey to France. At the same time, fuselage sections are starting their journey from Germany. And in Spain, the tail section is loaded onto a Beluga, Airbus' specially built transport aircraft. Two weeks later, the wings dock in France. They're about to embark on the trickiest part of their journey. They've been joined by all the other major sections of the plane, and the convoy heads off on a 240-kilometre journey through rural France. It's the middle of the night, and the whole convoy needs to drive through the medieval village of Levignac. The street is so narrow that Airbus had to redesign the balconies to make room for the wings. It's dawn, and the convoy arrives at the final assembly line in Toulouse. Paul Mackenzie, Broughton's overseas manager, is on his way to greet the wings.
When I was growing up, the one thing I always loved, we used to go every Sunday to Liverpool Airport to watch the aircraft. I always wanted to work in the aircraft industry.
It's the day of the marry-up, when all the parts of the plane that have been worked on for months in different countries finally come together.
I think this, without doubt, is, in terms of the A380, is the most critical point. Everything has to be absolutely right. Everything has to be absolutely spot on.
It's a fantastic feat of coordination, as the whole operation will take under an hour.
It's rather like a ballet of sorts. You have 5 teams choreographed, so everybody knows exactly what everybody else is doing. All the major components are simultaneously being moved into position. And ultimately, everything is moved into the jig, and then we begin with the assembly of yet another A380.
With the marry-up underway, everything is coming together at once in a clockwork manoeuvre.
It's an incredible sight to see every time. It never fails to amaze. It's a privilege to have been involved in the project, and I think that it goes without saying, for all the many thousands of people that have contributed to this, I think it's credit to all of those guys for the efforts that they put into it, you know, the determination, the commitment they've put in to get the product to this stage.
The moment is approaching when the wings will finally become part of an aircraft.
You see the centre fuselage ahead of us, and that area just behind the jack is the actual area that the wing will be married up to. OK, it looks like the guys are ready to start moving the wings into the fuselage, so I think we better move on.
The wings are finally joined to the plane with hair-width precision. and secured in place with 4,000 bolts. Over the next 14 days, the sections are joined together and other parts, like the landing gear, are attached. Next, 4 enormous engines are attached that can produce 300,000 pounds of thrust. It's put through Europe's largest paint shop, where they apply 1/2 ton of paint. And finally, the work is done, and the Super Jumbo is ready to leave the factory.
It's always a proud moment to see one leave. Every one of the team is devoted to this aircraft and making sure that it is the best aircraft, best quality that the customers deserve.
It's now a complete aircraft and ready for its maiden flight. The latest addition to a fleet that the company hopes will grow and grow over the next 25 years. But back in Broughton, it's just another working day.
Morning, John.
Hi, John, you all right?
Yeah, fine. You?
Yeah.
The number of wings coming off the line is now up by 50%, and these new orders will help secure jobs for the company.
We're changing the face of commercial aerospace industry. Passengers want to fly on A380, and when you see it in production, when you see the complete aircraft, I think you understand why. It's absolutely fantastic. Yeah, the A380 is an icon.
It's still only 4 years since its launch, but it seems that Airbus's big gamble might just have paid off. In the next programme, we go to iconic British company McLaren and discover how to build a supercar. From sketch to structure, see how designs come to life by visiting bbc.co.uk/how-to-build and follow the links to the Open University.